Lockout-tagout is a safety procedure that ensures machines are properly shut off and unable to be started up again during maintenance or repair work. This prevents the release of hazardous energy that could cause injuries or even fatalities. LOTO involves locking the equipment in the off position and tagging it to indicate that maintenance work is being done. Before we go further into our LOTO discussion, make sure to hit that subscribe button and ring the bell for more safety tips and training videos. Let's clear up a common confusion with the difference between lockout and tagout. Lockout is when you physically place a lock on the machine's power source, ensuring it can't be turned on. Tagout, on the other hand, involves placing a tag on the equipment that warns others not to operate it. While the lock physically prevents the machine from being turned on, the tag serves as a warning. However, tagging alone does not provide the same level of protection as locking. That's why lockout is generally preferred, with tagout as a supplementary measure. There are different types of energy sources that LOTO is designed to secure. These energy sources include electrical energy, which poses risks like shocks and electrocution, mechanical energy from moving parts that could cause injuries, hydraulic and pneumatic energy, which involve pressurized systems that could lead to sudden movements or burst. There is also the chemical energy, where reactive substances need to be controlled to prevent dangerous releases, thermal energy from high-temperature equipment that could cause burns, and gravity energy, which involves the potential danger of falling objects. Now, are all employees required to train for lockout-tagout? Not all employees are required to undergo full lockout-tagout training, but it's essential that everyone in the workplace has some level of awareness. There are three key groups that need lockout-tagout training. The authorized employees who are responsible for implementing LOTO procedures, affected employees who operate or use the machinery that may be locked out or tagged out, and the other employees who may be present in areas where LOTO is in effect. With lockout-tagout training, all employees understand the lockout-tagout practices, including when and how to apply LOTO procedures correctly. Without proper training, even a small mistake can lead to catastrophic outcomes. So, what should an effective lockout-tagout training program include? Let's break it down into three major components. Understanding hazardous energy sources. Employees need to identify different energy sources such as electrical, mechanical, hydraulic, pneumatic, chemical, and thermal energy that may pose risks. Lockout-tagout procedure. This includes detailed steps on shutting down, isolating, and securing machines, applying locks and tags, and verifying that the equipment is safely locked out. Hands-on practice. Training should offer real-world scenarios where employees can practice lockout-tagout procedures, reinforcing the correct steps and building confidence in their ability to perform LOTO safely. But sometimes, even with the best training, mistakes driven by human error can still happen. Here are some common pitfalls to watch out for in lockout-tagout. Failing to isolate all energy sources or neglecting to verify that energy has been fully de-energized. Using the wrong type of lock or tag, such as a standard padlock not designed for LOTO. Missing, illegible, or improperly placed tags can lead to confusion about the status of the equipment. Failure to identify and isolate all energy sources. Missing even one source can leave the equipment partially energized, posing a serious hazard. Incorrect application of lockout-tagout devices, such as breaker locks, plug lockout, and gate valve locks can render the lockout ineffective. Not providing or participating in regular LOTO training and refresher courses. Failing to include temporary or contract workers in training and safety briefings can lead to gaps in safety practices. Assuming that just because a machine appears to be off, it is safe to work on. Removing locks or tags before all work is completed and all workers are accounted for can result in accidental re-energization, putting workers at risk. Ignoring minor maintenance tasks like lubrication or adjustments may seem harmless, but they still require LOTO if they involve exposure to hazardous energy. Remember these final tips for effective lockout-tagout training. Regularly review and update training. Keep your lockout-tagout training updated with the latest OSHA standards and industry best practices. Encourage a safety-first culture. Promote the importance of safety and encourage workers to speak up if they notice unsafe conditions. Conduct audits. Regular audits help identify areas for improvement and ensure compliance with LOTO procedures. Thanks for watching. If you found this video helpful, give us a thumbs up and don't forget to share it with your team. Stay safe and see you in the next video.
Before using any equipment, you must first refer to the manufacturer's instructions for proper use, maintenance, and inspection of the equipment. Equipment must be inspected before each shift at a minimum. If the inspection reveals defects or damage beyond what is acceptable by the manufacturer's instructions or applicable legislation, it must be removed from service to be disposed of or repaired by qualified people. If the person doing the inspection is not yet competent in the inspection process, then a competent designated person needs to supervise the inspection. Makeshift rigging components are not permitted. All rigging components that carry any portion of a load must be commercially manufactured. These components are engineered and certified to comply with various standards. If you find any equipment that is in a condition that will compromise the health or safety of workers using or transporting it, you must immediately report it to your employer. This includes any equipment that will not perform the function for which it is intended, or for which it was designed, or is not strong enough for its purpose, or if it has an obvious defect. Workers involved in hoisting and rigging must exercise care when selecting and using slings. The selection of slings should be based on the size and type of the load, sling configuration, and the environmental conditions of the workplace. Improper use of slings may result in damage from overloading, excessive speed, or sudden acceleration or deceleration of equipment. Such damage can be caused by taking up slack with a sudden jerk or shock loading. Slings can be categorized in three main groups, which include chain slings, wire rope slings, and web slings. Each type has its own particular advantages and disadvantages. Factors to consider when choosing the best sling for the job include the size, weight, and shape of the load, the temperature and sensitivity of the material being moved, and the temperature and environmental conditions under which the sling will be used. Care should be taken when using chain slings because sudden shock loads can cause damage. Some advantages of chain slings include their strength, their resistance to the effects of UV light and hot temperatures, and their ability to withstand overall abuse from workers. Their biggest disadvantage is that the chain is only as strong as its weakest link, and they can fail without warning if used incorrectly. Chain slings must be visually inspected prior to use. During the inspection, pay particular attention to any link elongation, bends, twists, heat damage, nicks, gouges, and wear in excess of the allowances made by the manufacturer. These signs indicate that the sling may be unsafe and must be removed from service immediately, as it may break suddenly without warning. For this reason, some sites do not allow chains for hoisting, so you must know your site-specific rules and regulations. When chains are used for adjusting the load, backup slings may be required as a site standard. Wire rope slings have great strength combined with flexibility. They don't wear as rapidly as other slings, and their true condition is shown by the presence of broken wires. When selecting a wire rope sling to give the best service, there are 4 characteristics to consider: its strength, its ability to withstand fatigue, for example, its ability to bend without distortion, its ability to withstand abrasive wear, and its ability to withstand abuse. Wire rope is composed of individual wires that have been twisted to form strands. Strands are then twisted to form a wire rope. When wire rope has a fiber core, it is usually more flexible, but less resistant to environmental and heat damage. Wire rope with a core that is made of wire rope strand tends to have greater strength and is more resistant to environmental and heat damage. The term rope lay signifies the direction of rotation of the wire and the strand. Rotation is either to the right, being clockwise, or to the left, being counterclockwise. The lay length is the distance measured along the rope in which a strand makes one complete revolution around the axis. In regular lay rope, the strands rotate in the direction opposite to which the wires rotate. This is to counteract the torque in the rope and reduce the tendency of unwinding under load. Most wire rope used is right lay, regular lay. This type has the widest range of applications and meets the requirements of most equipment. As you can see in the illustration, with regular lay rope, the wires appear to be running horizontally. In Lang lay rope, the strands rotate in the same direction as the wires. The wires appear to run diagonally. These ropes are used in special applications where torque would cause the line to twist in one direction. Lang lay rope is 20% weaker than regular lay rope. Wire rope and chain slings must be protected with softeners or blocking when used at corners or sharp bends. The length of the arc of the softener must contact the rope for at least one rope lay. Not doing so is the most common cause of damage to wire rope. Inspect wire rope for kinks, broken wires, abrasion, crushed strands, corrosion, electric arc, metal fatigue, diameter reduction, wire rope stretch, scrubbing, and exposed bulging core. The ropes illustrated here show the severe damage that results when kinked ropes are used. Local wear, distortion, misplaced wires, and early failure are inevitable. Bird caging may be caused by a sudden release of tension and resultant rebound of rope from overloaded conditions. One of the biggest concerns with distortion in the shape of the wire rope slings is that the wires are no longer carrying an equal share of the load. Wire ropes must be removed from service if wear or corrosion affects individual wires over more than 1/3 of the original diameter of the rope. There is evidence that the rope structure is distorted because of bulging, kinking, stretching, bird caging, or any other form of damage. They must also be removed from service if the normal rope diameter is reduced from any cause by more than 0.4 mm if the normal diameter is 8 mm or less, 1 mm if the normal diameter is more than 8 mm and less than 20 mm, 2 mm if the normal diameter is 20 mm or more to less than 30 mm, and 3 mm if the normal diameter is 30 mm or more. Running ropes are ropes that run over a sheave or a drum. Running wire ropes must be removed from service if 6 or more randomly distributed wires are broken in one rope lay, or if 3 or more wires are broken in one strand in one rope lay.
In this video, we'll take a comprehensive look at incidents involving workers struck by and caught in between hazards, but we won't just talk about the problems. We'll identify the types of operations most prone to these hazards and arm you with the know-how to combat them effectively. This module is split into 2 lessons. First up, the struck by hazard, followed by the equally crucial, caught in between hazards. But wait, we've got more in store. Let's unlock those terms buzzing around this module. Ever heard of audible backup alarms? These little lifesavers are a must on heavy construction vehicles, alerting nearby workers to potential danger when a vehicle reverses. Speaking of safety, a chalk might just be the unsung hero preventing vehicle roll-offs on inclines. Excavation work, an essential part of construction but a major hotspot for caught in between hazards. Did you know that most citations for these hazards back in 2005 were tied to excavation operations? Enter the limited access zone, creating a clear boundary around masonry wall construction, ensuring only essential employees have access. Ever wondered what PSI stands for? It's the pressure per square inch, a vital measure for compressed air used on the site. Let's talk about shoring, those sturdy structures like metal hydraulic or timber shoring systems. They're your go-to defenses against dreaded cave-ins in excavations. And toe boards. Think of them as the silent guardians along scaffold platforms, keeping tools and objects from plummeting and risking harm to workers below. Remember, installing toe boards is a smart engineering move for safety. Welcome to the first lesson about struck by hazard. Imagine a tool falling from above, hitting you hard. It's scary and painful, and you hope someone will come to help. Many workers face this danger. but safety rules can keep you safe from such accidents. Now, think about workers navigating near public roadways, exposed to the potential of being struck by passing trucks, cars, or other vehicles. These dangers aren't just limited to the roads, they can lurk in everyday workplaces too. But fear not, we've got a safety toolbox filled with engineering controls to shield you from harm. Always remember these crucial controls. First, the life-saving vehicle backup alarms. Install, use, and maintain them diligently. Position flaggers strategically behind vehicles with limited rear views. Keep non-essential workers clear of vehicle zones and steer clear of temporary overhead activities. Use barriers and warning signs to shield hazardous operations and roadways. When it comes to cranes and hoists, safety is non-negotiable. Never allow employees beneath loads in motion. Cordon off areas and display warning signs to keep non-essential personnel away from overhead equipment. Inspect cranes and hoists meticulously before every use to ensure they're in tip-top shape. And remember, never push cranes and hoists beyond their lifting capacities. Here's a critical reminder. Prohibit workers from driving equipment in reverse without proper alarms or flaggers in place. Proper maintenance of vehicles and their operating surfaces is key to eliminating many struck-by injuries. Injuries from flying or falling objects can range from minor bruises to severe consequences like concussions, blindness, or worse, death. Wrapping up with a final safety tip, secure unrolled wire mesh effectively to prevent dangerous recoil. Let's take a peek at the study questions. Brace yourselves for the second lesson about caught in between hazards. Imagine being stuck between giant machines, unable to move, fear gripping your heart. You pray for help, knowing one wrong move could mean the end. It's a real fear for workers, yet preventable with basic safety precautions. Let's dig into these imperative key points. Always stack building materials smartly, keeping them clear of work areas to prevent sudden shifts or slides that could endanger workers. Operational plans should carve out adequate space for moving suspended loads safely. Ensure ample space around material stacks and wide walkways, allowing workers to dodge sliding swiftly or accidentally nudged materials. Never step into an unprotected trench deeper than 5 feet without the proper safeguards. Some shallower trenches might also need protective systems like sloping, shoring, benching, or trench shields. Even some shallower trenches may warrant such protective measures. And now, the study questions await. Now, let's move to heartfelt reality. In 2020, tragedy struck within the heart of construction sites. It wasn't just numbers or statistics. It was 150 lives lost and 14,000 souls scarred by struck-by incidents. But it didn't end there. 140 workers were caught in between. Imagine the wrenching pain, the families shattered, and the dreams abruptly ended. It's not just a statistical surge, it's a cry for change, a plea for safety, a call for a better tomorrow. Here are some crucial life-saving tips to keep in mind while on the job. Firstly, when working in a trench, ensure that heavy equipment and excavated soil are kept at least 2 feet away from the trench edges. This distance can differ between a safe environment and a potentially hazardous situation. Regular inspections are vital. Take the time to thoroughly examine tools, machinery, and equipment to ensure they work properly. Your diligence could prevent accidents and save lives. Clear communication is key. Whether operating machinery or working in an area with potential hazards, maintaining open and concise communication with your team members is crucial for everyone's safety. When it comes to moving equipment, always walk behind it whenever possible. This simple act significantly reduces the risk of accidents and ensures your safety. Stay vigilant and be aware of the equipment surrounding you at all times. Keeping a safe distance from machinery reduces the risk of accidents and injury. Avoid positioning yourself between moving materials and immovable structures, vehicles, or stacked materials. It's a potentially dangerous situation that should be avoided at all costs. Lastly, and most importantly, ensure that all workers receive proper training on safety protocols, hazard identification, and emergency procedures. Knowledge and preparedness are our strongest allies in ensuring a safe work environment for everyone involved. And here's your chance. Got any queries or thoughts to share? Don't hesitate, the comment section below is all yours. As we gear up for Module 7, brace yourselves for even more excitement ahead. Remember to subscribe and press the bell icon to stay updated. Until then, take care and stay safe.
In this quick video, we'll discuss confined space entry permits. In the next few minutes, we'll break down everything you need to know about the permit system that keeps workers safe in confined spaces. Every year, workers lose their lives in confined spaces because of improper entry procedures. The permit system isn't just paperwork, it's a critical lifeline that prevents tragedies. Let's start with the basics. A confined space entry permit is a written document that authorizes specific employees to enter a confined space. Think of it as your safety passport. Without a valid permit, no one should ever enter a permit-required confined space. Now you might be wondering, when do I need a permit? The answer is straightforward. If your confined space contains any of these hazards, you need a permit. Hazardous atmospheres, engulfment hazards, trapping or asphyxiation configurations, or any other serious safety threats. Other examples include storage tanks, manholes, sewers, and ventilation ducts. Here's what makes a permit valid. First, it must be signed by the entry supervisor. This person has verified all safety measures are in place. Second, the permit must list every person authorized to enter. Third, it needs to specify the duration, when it starts and when it expires. And fourth, it must document all safety measures, including atmospheric testing results. Let's talk about common mistakes that can invalidate your permit. Writing illegible information, leaving sections blank, or failing to conduct all required atmospheric tests. These seemingly small errors can have serious consequences. Always double-check your permit before entry. Your permit should always include these critical pieces of information: the space location and purpose of entry, entry duration, authorized entrance and attendance, known hazards, control measures, acceptable entry conditions, testing results, and emergency contact information. Here's a real-world scenario. A maintenance team needs to enter a storage tank for repairs. Before anyone enters, the supervisor completes the permit, documenting oxygen levels, flammable gas readings, and toxic substance measurements. They verify ventilation is running and rescue equipment is ready. Only then do they sign the permit and allow entry. Remember, permits expire. If work extends beyond the authorized time, you need a new permit. If conditions change, evacuate immediately and get a new permit. Never take shortcuts with permit procedures. Documentation is crucial. Keep all permits for at least 1 year. They help identify patterns, improve safety measures, and comply with OSHA requirements. They're also vital if incidents occur. Let's recap the key points. Always check if a space requires a permit. Ensure all sections are completely and accurately filled out. Verify all safety measures are in place. Keep permits on site during entry. Document everything and never enter without a valid permit. Your life and the lives of your coworkers depend on following proper permit procedures. No job is so urgent that we can't take time to do it safely.
Are you fed up with sifting through binders trying to find the right toolbox talk? Safe Leo can put an end to that headache once and for all. You'll never ever have to comb through binders again. Now you can easily upload your own or choose from our comprehensive library of preloaded text-based and video-based toolbox talks. No more last-minute scrambling to pull something together. Even better, you can bulk schedule those talks across all your projects ensuring they happen consistently without someone having to remember. When it's time for the safety meeting, just pull up the day's talk on your phone or tablet and deliver it to your crew. Taking attendance is a breeze too. Workers can digitally sign in right on the device, or you can snap a photo of the physical sign-in sheet. Either way, SafelyO keeps everything documented and stored in one organized system. Safety should be the top priority on any job site. Now you can streamline your toolbox talk so you can focus on the information, not scrambling to find it. Click the link below to request a quick demo.
Do you work with or around machines or use power tools? If so, you would probably think twice about wearing loose clothing in your workplace, including shoes that pose a trip hazard or lanyards and other objects hanging around your neck. In your line of work, what type of clothing you put on and how well it fits might make the difference between dismemberment or even death. The utility of power tools and equipment, whether electrical, pneumatic, hydraulic, or any other method of mechanical powering, comes with a slew of dangers for their operators. Machine safeguarding requirements are in place to give operators their best chance at safe use. Both administrative control measures that govern how equipment is used, maintained, or otherwise interacted with, as well as engineering control measures that seek to remove or separate employees from hazards, are important in machine safeguarding. As we just discussed, you have some control over your safety in your choice of clothing each workday. But your safety is more than a matter of clothing choice. Hazard awareness, well-maintained equipment guards, and other safety devices and practices play a huge part in keeping you and your coworkers safe on the job. In this training, you'll learn to identify common machine hazards and the types of safeguards that should be employed to protect against those hazards. We will also explore how the proper use of personal protective equipment can act as your last line of defense against the dangers of machine use. This training will also help you build your understanding of how equipment maintenance, repair practices, machine stability precautions, proper tool use and guarding, and other safe work practices tie into machine safeguarding requirements. Before operating any piece of equipment, all potential health risks should be understood and accounted for. This is part of a standard Job Hazard Analysis, or JHA, process. Machine guarding involves protecting workers from hazards at what is called the point of operation. These hazards can include nip points, rotating parts, and flying chips or sparks. Depending on the circumstances, other hazards such as noxious fumes, danger from falling objects, or equipment tip-overs and proximity to other equipment might also come into play. According to OSHA statistics, approximately 18,000 employees who work with machinery experience amputations, crushing injuries, abrasions, and lacerations annually. These can result in permanent disability. Add to that over 800 deaths each year, and machine operation becomes a deadly serious business. Think about the tools and equipment you work with or around. Are you at risk of amputations, pinch points, having loose clothing pulled into moving parts, or exposure to flying materials or sparks? Examples of machines you might encounter that typically require point of operation guarding include cutters and shears, robotics and other automation equipment, power presses and forming rolls, belt, chain, or shaft-driven equipment, milling machines, power saws and portable power tools, and even conveyor belts, which are used to transport materials from one location to another. The exact nature and severity of an injury a machine might cause you depends on the circumstances. Besides amputations and other serious crushing injuries, burns and blindness are also common, and highly traumatic injuries. As a team, workers and supervisors should review the dangers associated with any tools and equipment. If it involves moving parts, sharp edges or material burns, hot surfaces, or any processes or component that might cause injury, it should be safeguarded. Basically, any process that involves spinning, shearing, bending, oscillations or reciprocation, side-to-side motions, cutting or punching. Watch out. A safeguard or system of guards should be in place. These typically are witnessed at the side of a power transmission device, such as a flywheel, pulley, belt, connecting rod, chain, crank, gears, and other mechanical components where energy is transmitted during operation. Along with these equipment-related hazards, never forget that the infamous Fatal 4 may be lurking, depending on the nature of your workspace and machinery or tools. These include falls along with slips and trips, the potential to be struck by objects, electrocutions, and being caught in or between objects. The different types of machine guarding devices are designed with these in mind as well, but safe work practices and an awareness of these hazards have no substitute. So what exactly is a safeguard, and what are some examples? A safeguard is any process that prevents against contact between an operator's body, including their clothing and PPE, and moving mechanical parts or materials. A basic example would be a guard over the blade of a table saw. This both protects against the entry of a body part into the path of the rotating blade and also protects against flying sawdust, wood chips, sparks, and other debris. The table saw scenario is just one example of a safeguard. Guards come in many different types to meet the various requirements for equipment and workplace layouts. They might be fixed in place, movable, or adjustable, or even interlocked where the interlock devices are used in tandem with barrier guards. Interlocks are setups where two functions or mechanisms are mutually dependent on the other in order to operate. Guards might not only include just physical barriers, often they're integrated safety switches, as in the case of two-hand tripping devices, known ominously as deadman switches, or electronic safety devices like optical sensors to shut down a machine or prevent it from starting up if a person or other object is within certain space. Common switches include devices to sense whether a gate or cover is closed before energizing a circuit. For example, where a crush hazard exists, an electronic interlock device might be integrated into a door panel, only allowing operation when the door is properly shut. Interlocks are commonly employed in operations involving revolving drums, barrels, and other containers. As a general rule, restarting equipment should require some deliberate action, with all movable or adjustable barriers in the closed or starting position. These devices can all be bypassed with a little creativity, but defeating safeguards can have deadly consequences. Guards should be affixed directly to each machine wherever possible. They can be secured somewhere else if that's not possible. Clearly, the guard itself should not present a hazard. Common hazards to avoid might include snagging, tripping, or requiring workers to duck down to do their work. There are often published standards for specific machine guarding expectations. If a standard does not exist, the basic requirement is to at least prevent an operator from having any part of their body in the danger zone, while the equipment or tool is in operation. Ideally, these machines and equipment will already be equipped with proper guards and safeties. Any tooling changes in personnel or operating method, addition or removal of auxiliary equipment, machine or system modifications, part configuration, or adjustment in safeguarding design or placement may affect safeguarding. Be ready to adjust the safeguarding or add supplemental safeguarding in the event of alterations in the operating program or related considerations. Any adjustments of safeguards, such as movable barrier devices or electronic interlocks, must be performed by authorized personnel only. Do you know where and what type of guards are in place for the equipment and tools you work with? Could you tell if they were functioning properly? Whom would you ask for assistance or maintenance? It's important for you to know the answers to these questions. If you don't know, find out. There are several general rules for safeguards. Some we already discussed, which are that safeguards should prevent contact between the equipment and body parts or clothing, and that safeguards must also not create a new hazard. If the guard presents a new hazard, such as a jagged edge or shear point, or obstruction of an operator's line of sight, it defeats the purpose of machine guarding. In addition, safeguards must stay secure and not be easily tampered with or removed. To help prevent tampering, there are often extra steps designed into the removal process, and the components are made of higher quality materials. They should also prevent objects from falling into machinery and moving parts. Safeguards need to be designed in a way that allows for safe maintenance. For example, lubrication and machine inspection ideally can be completed without needing to remove the guards. They must also create no interference in operation. If a safeguard prevents operators from doing their job as efficiently or quickly as with it removed, this encourages workers to bypass the safeguards. Depending on the exact nature of your work, specific regulations may apply. For instance, the requirements for guarding exposed fan blades that are less than 7 feet above the floor or working level are very specific. Guard openings can be no longer than half an inch. Highly specific regulations may exist for your workspace. Be sure to identify all hazards that are unique to your tasks, and then ensure you're aware of and in compliance with all requirements. A good place to start is the equipment manufacturer or distributor. The hazards that are specific to your work will determine the type of personal protective equipment or PPE you must use. For example, highly reflective surfaces and the use of lasers or production of high-intensity light, as in the case of welding processes, might dramatically change the type of eye and face protection employed. PPE is important, but it is a worker's last line of defense against a hazard. Each employee is responsible for avoiding known hazards and must never attempt to bypass safeguarding. It's better to have to replace a glove due to age or regular wear versus because it was yanked off or sliced open by a machine part. For additional training on PPE selection and use, check out our other safety titles. New employees or operators who have been away for an extended period or who are learning to work on new machinery should especially be given training on PPE, emergency response, conducting a job hazard analysis, and other safe work practices. Employers are responsible for providing proper PPE and replacing it when necessary. Take a look around at the equipment you work with. Is it new? Probably not. Everything wears down over time. Maintenance and replacement schedules of these wear parts is needed to keep guards and other equipment components operating correctly. Imagine hitting an emergency stop button for a conveyor belt and it takes twice as long to stop moving stock as it did when it was brand new. Yeah, that's a problem. Machine and tool guards should be replaced when they're no longer safe to use. You can determine this through daily visual inspections and implementation of a preventative maintenance and replacement schedule. All guards require regular maintenance and tightening to be kept in safe operating condition. Far too often, employees habitually defeat machine guards because they believe it makes work easier or more efficient. Well, there's nothing efficient about having body parts amputated or crushed due to improperly guarded equipment. A basic factor in safe equipment operation is the presence of a kill switch. OSHA dictates that a mechanical or electrical power control shall be provided on each machine to make it possible for the operator to cut off the power from each machine without leaving their position at the point of operation. Oftentimes, these switches build up grime or are obscured or even just forgotten. They can even fail. So, it's important that these controls are tested regularly, replaced when necessary, and that all operators, supervisors, and personnel who work nearby are aware of them and any auxiliary methods of de-energizing the equipment. By their nature, machines include moving parts. This movement causes vibration and changes in the equipment's balance and center of mass. Often, vibrations are engineered out through the use of springs and energy-absorbing materials in the equipment design. But these are never perfect, and their effectiveness drifts over time. Vibrations can cause equipment to literally walk out of its normal space, which can wreak havoc in an industry where equipment placement is directly related to safety. These vibrations can also lead to equipment toppling over, or tools and materials falling off of attached shelves. This is why machines that are designed for a fixed location must be securely anchored. Anchoring might involve bolting the equipment down to the floor or even attaching it to the wall. If you work with equipment that's fixed in place, have you ever noticed any anchoring methods? Other considerations with machine and tool safety include identifying hazards from repetitive motions, travel or toppling over of equipment, tools that can cause continuous or severe vibrations, exposure to contaminants from tool and equipment use, electrical hazards, and so forth. You, your coworkers, and your employer should continuously work together to identify safe work practices and ways to minimize risk to yourself and others in your work environment. Remember, if a hazard can be identified, the potential incident can be predicted. And if an incident can be predicted, you can guard against injury or illness and be ready for emergency response. Successfully navigating your work environment and keeping others safe in the process also involves a strong situational awareness. Situational awareness is when you understand the interaction of people and equipment in a given environment. It is this lack of situational awareness that often leads to equipment damage and, of course, workplace injuries and fatalities. To aid with situational awareness, safeguards are sometimes in place that provide a recognizable sound or light signal of impending or present hazards. These are known as awareness signals, and they are employed side by side with proper hazard communication signage, labels, and tags. One commonly applied safeguarding aid is the use of automated feeding and ejection methods. For example, in a lumber mill, instead of loading materials manually, operators can avoid exposure to the points of operation through the use of mechanized cranes and other stock handling devices. These can be automated using robotics, shifting the human factor away from typical loading and material movement hazards. This same practice applies to the movements of cylinders and other containers, emptying of drip pans, and waste stock removal. In addition to what you've learned here, the OSHA.gov website houses resources that offer expanded hazard recognition tips and safeguarding strategies. As you build out or revisit hazard response programs specific to your place of work, be sure to explore how your industry peers have established safe and compliant work environments. The safeguarding industry is always evolving, so keep in touch with your equipment supplier on safeguarding practices as your equipment ages or requires repair. Take a walk through your area or equipment storage facility. What safeguards are in place? Think about what hazards you or your employees risk when operating that machinery or those tools. Is everything in place to protect you during operation? Related trainings are available to take your team to the next level in safe equipment and tool operation. Lockout Tagout is a great place to start, along with the safety preparation and emergency response topics referenced throughout this machine guarding training. Throughout this training, you were asked to relate safety and machine guarding techniques to your own work environment. We identified common hazards from equipment operation, types of safeguards and their requirements, personal protective equipment, maintenance and repair, and many other considerations that apply to typical machine safeguarding scenarios. Safety is engineered into well-designed machinery. However, proper operation, maintenance, and awareness of equipment hazards depend on the safety culture of your workplace. you play a key part in your own safety and that of your coworkers. If you have a concern, speak up. Whether you're a supervisor or a frontline worker, you have both the right and the responsibility to point out safety issues.